let's see another example. The example of the redox reaction of phosphorus, sodium hydroxide, and water particle. We obtain phosphine particle and the acidic salt of phosphine acid. Yes, this compound is a salt of sodium and phosphine acid. This is sodium dihydrogen phosphine. Yes. Okay. So in the electrolyte solution, of course, this example is also aqueous electrolyte solution. Why aqueous electrolyte solution? To be able to show you this second method utilizing water particles, hydrogen ions, cations, and hydroxide anions. Okay, in water solution, in aqueous solution, it dissociate into sodium cation and this the hydrogen phosphine anion with the charge equal to minus 1. Okay, so let's find something that undergoes oxidation and reduction reaction. Let's start from phosphorus. Yes, phosphorus on the left side of the reaction, so in the substrate is its oxidation state is equal to 0. Okay, because phosphorus stand alone. Yes, it is non-metal. He stand alone in this reaction. He is not connected to other different elements, so the oxidation state is equal to 0. Okay, so let's find the phosphorus on the right side of the reaction. In the first example, in the first particle, we have phosphorus atom. Yes, in this compound, the phosphorus oxidation state is equal to -3 because hydrogen oxidation state is equal to +1 because hydrogen has lower electronegativity than phosphorus. Yes. Okay, so 3 hydrogen atoms give us oxidation state equal to +3. So the phosphorus oxidation state needs to be equal to -3. Okay, so we found the reduction reaction from oxidation state equal to 0 to oxidation state equal to -3. So we have reduction reaction, oxidation state equal to 0 to oxidation state equal to -3. Okay, what else? Let's check sodium. Sodium in the sodium hydroxide oxidation state is equal to +1. In this salt containing sodium and phosphine acid, the sodium oxidation state is also equal to +1. So we are sure now that the sodium do not change his oxidation state. Okay, what about the oxygen? Here in sodium hydroxide, the oxygen atom oxidation state is equal to -2, as well as in the water particle. Okay, where is the oxygen atom? Where are the oxygen atoms? On the right side of the arrow, so in the product. Here we have it in this sodium salt, in sodium dihydrogen phosphine salt. In this salt, oxygen atom oxidation states are equal also to minus 2. Yes, this is not extraordinary example here. So we could see that oxygen atom do not change his oxidation state. Okay, what about the hydrogen atoms? We have one in sodium hydroxide and one and two in water particle. Three of them, these three hydrogen atoms, oxidation state is equal to +1. On the right side of the reaction, we have two hydrogen atoms in this salt. In this salt, the oxidation state of hydrogen is also equal to +1. Also equal to +1. Okay, so we are sure now that there is no change of oxidation state of hydrogen atoms, yes? Okay, so what else? I think we check everything. So where is the oxidation reaction? Because you remember that if we had a reduction reaction, we also need to have oxidation reaction. Yes, the both of these reactions proceed together. Yes. So what's happened? What could we check to be sure that we can't find oxidation reaction? What about what we forget? Let's see this phosphorus atom in this salt here. Let's check this salt once again. Let's check the structure of this salt once again. Okay. This salt is neutral particle, yes, so the net charge of this particle is equal to 0. The oxidation state of sodium, of course, is equal to +1. The oxidation state of hydrogen also also +1. We have two hydrogen atoms, so the total oxidation state +2. Oxidation state of oxygen -2 from two atoms give us -4. +1 +2 give us +3. -4 it is -1. -1. So the oxidation state of this phosphorus need to be equal to +1. Okay, so +1. I will clear it to make some space. So we are sure now that the oxidation state of this phosphorus atom in this salt is equal to +1. So we found oxidation reaction, yes? Oxidation reaction from the oxidation state equal to 0 to oxidation state equal to +1. So let's see that the same atoms of phosphorus, that which stand alone, undergoes reduction as well as oxidation reactions. Yes, this kind of redox reaction is called disproportionation reaction. Yes, so from the one oxidation state of one element, we can obtain the same element but in two different oxidation states, in two different compounds. Here as a phosphine and here as a salt with sodium and phosphine acid. Yes, so we get here sodium dihydrogen phosphine here. Okay, so let's firstly try to solve these coefficients with the first method. I mean the method utilizing only oxidation states of the atoms. Yes, so oxidation reaction from phosphorus with the oxidation state equal to 0 to phosphorus with the oxidation state equal to plus 1. And of course, one electron on the right side of this equation. Okay, reduction reaction from phosphorus with oxidation state equal to 0 to phosphorus atom in the particle of phosphine where the oxidation state is equal to minus 3. Okay, so how many electrons do we need here in this reaction? 3 electrons. Okay, do you remember what is the next step? The next step is to balance the electrons between these two half cell reactions. So we need to multiply the first reaction by 3. And here we get the new oxidation reaction with the new coefficients. We have 2 atoms of phosphorus, which give us 3 atoms of phosphorus with the oxidation state equal to plus 1, and of course 3 electrons. Okay, so let's try to write now the overall reaction. Yes, overall reaction. So on the left side we have all of the substrates, and on the right side we have all of the products. Okay, so we have one atom phosphorus here with the oxidation state equal to 0, and below we have also 3 atoms with the same phosphorus atom. So we have together 3 atoms of the phosphorus with the oxidation state equal to 0. Okay. We do not use electrons. We do not use electrons in the overall reaction, yes. So and I think it's everything we have on the right side, on the left, side of the overall reaction. Let's look at the right side of the reaction. We have 3 phosphorus atoms with the oxidation state equal to plus 1, and we have, what do we have else? And we have 1 phosphorus atom with the oxidation state equal to minus 3. Okay, so we can now fill the coefficients of the main reaction, which is provided on the top of this page. 3 atom phosphorus with oxidation state equal to 0. So we put the 4 in the front of this atom. What else? 3 atoms of phosphorus with the oxidation state equal to plus 1. So we get here 3. Okay, so 3 in the front of this salt, in the front of this sodium salt. Okay, what else? In the front of this atom there is 1. So we have 1 atom of the phosphorus with oxidation equal to minus 3. So we have only 1 particle of phosphine here. Okay, so we can balance the other elements. Yes, on the left side of the reaction we have only one atom of sodium. On the right side we have 3 atoms of sodium. So we need to put 3 in the front of the sodium hydroxide. Okay, so on the right side we have 3 atoms of hydrogen, and in this phosphine, and in the 3 particles of this salt there are 6 atoms of hydrogen. So we get together 9 atoms of hydrogen. In sodium hydroxide, in 3 particles of sodium hydroxide, we have 3 atoms of hydrogen. So we need 3 particles of water, which give us in total on the left side 9 atoms of hydrogen. So to be sure, let's just check the oxygen atoms. Yes, on the left side we have 3 oxygen atoms in 3 sodium hydroxide particles and 3 oxygen atoms in 3 particles of water. So in total we have 6 oxygen atoms. So on the right side, we have also need to have 6 oxygen atoms. Do we have it? Yes, we have it because we have 3 particles of sodium dihydrogen phosphine. In one, there are 2 atoms of oxygen. We have 3, so in total we have 6 atoms of oxygen. Okay, so now let's check the this more sophisticated method. Yes, method utilizing ions.